Now, let's move to exercise 4.2 on indices. First question says, number 1, we should simplify and leave our answer in index form. A is 2 raised power 2 times 2 raised power 4. Everybody knows how to do this. That should be 2 raised power 2 plus 4. And that should be 2 raised power 6. So I'm leaving my answer in index form here. I think before I continue, I should quickly, or maybe I'll just do a few first, then I'll state the loss of indices. 5 raised power 2. This will give me 5 raised power 6 plus 2, and that will give me 5 raised power 8. That's how we use some basic loss of indices. Let's quickly state the loss here before we continue. The loss of indices are just about 5 or 6 mainly. First law of indices states that a raised power x times a raised power y should be a raised power x plus y. We say when the bases are the same, we add the indices. Second law says a raised power x divided by a raised power y should be treated as a raised power x minus y. When dividing and the bases are the same, we just subtract the indices. That's a brief explanation for that. Third law says a raised to power 0 is equal to 1. In fact, anything raised to power 0 gives us 1, whether negative, positive, big or small number. Anything raised to power 0 gives 1. Fourth law says a raised to power minus x is the same thing as 1 over a raised to power x. So this means a negative index just means 1 over a raised to power the positive index here. So this is another very important law of indices. Then number 5, fifth law of indices states that a raised to power x over y is equal to, let me write vertically, a raised to power x over y is equal to y root a raised to power x. We can simplify this like this, or y root a raised to power x. So any of these two is a good interpretation of the fifth law. The sixth law of indices says a raised to power x in brackets raised to power y should be treated as this, a raised to power x times 1 or a raised to power x y. So when we have brackets around our powers like this, we just multiply them. There's another tricky one. Let's take that as the seventh law of indices, which says that a over b raised to power minus x over y should be treated as b over a raised to power x over y. So here we just switch a and b here, or swap a and b here, and change it to b over a, and we throw the minus sign in our fractional index away. So those are some basic laws of indices. I think I remember a last one which states that something like 2 raised to power x times 3 raised to power x should be treated like 2 times 3 raised to power x. So that means I can write that law as a raised to power x times b raised to power x should be treated as a times b raised to power x. Let's make that our last law of indices. Now let me continue with my exercise. I've done A and B. I think I'm going to C now. Question C says 10 raised to power 5 times 10 raised to power 7 times 10 is to be simplified. This will give me 10 raised to power 5 times 10 raised to power 7 times 10 raised to power 1. 10 is the same thing as 10 raised to power 1. That's 10 raised to power 5 plus 7 plus 1. And that's 10 raised to power 13. As long as I'm leaving my answer in index 1. Question D says x raised to power 7 times x. That's the same as x raised to power 7 times x raised to power 1. X is the same as x raised to power 1. So what does that give me? That gives me x raised to power 7 plus 1, and that gives me x raised to power 8. Question E is a raised to power 3 times a raised to power 2 times a. This is the same thing as a raised to power 3 times a raised to power 2 times a raised to power 1. So I'm only to put the indices together and add them up, and I will get a raised to power 6. Question F is a bit tricky. That's 5 squared a times 5 raised to power 4 a raised to power 3. I'm going to put the numbers together here. Let me change my marker. I'm going to put the numbers together. 5 raised to power 2 times 5 raised to power 4 together. Then 8 times a raised to power 3 also together. So my answer on next step will be 5 raised to power 2 plus 4. A is the same thing as a raised to power 1. A is the same thing as a raised to power 1. Excuse me there. A is the same thing as a raised to power 1. A is the same thing as a raised to power 1. So I have a raised to power 1 times a raised to power 3. I can put that together too as the, let me write it for 5 raised to power 6 times a raised to power 1 plus 3. I'm sorry I didn't write the times here. So that gives me 5 raised to power 6 times a raised to power 4. I will leave my answer at 5 raised to power 6 a raised to power 4. That's question F. Let me go to G now. Question G says, in G, I'm to simplify a raised to power 8 divided by a raised to power 4. That will be a raised to power 8 minus 4. Since I'm dividing, I'll be subtracting my indices. So that should give me a raised to power 8 minus 4 is 4. H. Question H. 6x raised to power 6 divided by x divided by x raised to power 3. This is 6, then times x raised to power 6 divided by x, or I can write it like this. Let me make it simpler. This is 6x raised to power 6 over x raised to power 3. So this is 6 times x raised to power 6 over x raised to power 3. That's going to give me 6 times x raised to power 6 divided by x raised to power 3. And that leads to 6 times x raised to power 6 minus 3. 6 times x raised to power 3. I'll leave my answer like that. That's the question R. B raised to power 3 times b raised to power 4 times b raised to power 5 all over b raised to power 3 times b raised to power 4 times b raised to power 5 all over b raised to power 6 times b. I'm just going to, put the numerator in one form. In one piece, 3 plus 4 plus 5. Do the same thing to the denominator. B is the same thing as b raised to power 1, so just add 6 to 1. Here, this will give me b raised to power 12, and on the denominator side, I'll get b raised to power 7. So essentially, I'm dividing b raised to power 12 by b raised to power 7, and I can write that as b raised to power 12 divided by b raised to power 7. So that gives me b raised to power 12 minus 7, b raised to power 4. G. 8a raised to power 3 over 2a squared. I can just separate the numbers. 8 over 2 times a raised to power 3 over 8 over a squared. 8 over 2 is 4. So I have 4 times a raised to power 3 divided by a squared. That gives me 4 times a raised to power 3 minus 2. 4 times a raised to power 1. 4a raised to power 1. Since I'm leaving my number answer in index form, any of the two last forms are correct. Is correct, 5 raised to power x minus 1 times 5 raised to power 1 minus x will be treated as 5 raised to power x minus 1 plus 1 minus x, and that will lead to 5 raised to power x minus 1 plus 1 minus x. I think I should put the common factors together. 5 raised to power x minus x minus 1 plus 1. That will lead to 5 raised to power 0. That will lead to 5 raised to power 0 plus 0. 5 raised to power 0. 1. Now, question L. 5y raised to power 4 times 3y raised to power 5 times y. First of all, let me put indices on every item. This is 5y raised to power 4 times 3 y raised to power 5 times y raised to power 1. So I put the numbers together. 5 times 3 times y raised to power 4 times y raised to power 5, excuse me, times y raised to power 1. 5 times 3 gives what? 15 times 15 times y raised to power 4 plus 5 plus 1. I think that's what I have here. 4 plus 5 plus 1. Let me show that. 4 plus 5 plus 1. Since they are all multiplied, I can just add their indices of 4 plus 5 plus 1. That gives 15 times y raised to power 10. So 15y raised to power 10. Now let's move to question 2. I'm to simplify the questions in number 2. First question, 10 raised to power 3 times 10 raised to power 2. This will give 10 raised to power 3 plus 2, 10 raised to power 5, and that will give 1, 2, 3, 4, 5. That's 10 raised to power 3 plus 10 raised to power 2. Question B, 7 raised to power 8 times 7 raised to power minus 8. Bases are the same and the powers are to be added. 7 raised to power 8 plus minus 8. That's going to lead to 7 raised to power 8 plus times minus here will give me minus, because the bracket means multiplication. So this is plus times minus. 7 raised to power 8 minus 8 gives 7 raised to power 0, 1. Question C, 15 a raised to power 0. This is the same thing as 15 times a raised to power 0, or 15 times 1, 15. Question 2D, 6 raised to power minus 1 is the same thing as 1 over 6 raised to power 1, or simply 1 over 6. Question E, 2 raised to power minus 4 is the same thing as 1 over 2 raised to power 4, or simply 1 over 2 times 2 times 2, 4 times, let me try and write that word, times 2, and that's 1 over 16. Question, let me put it later. Question F is 7a raised to power minus 3. This means the same thing as 1 over 7a raised to power 3. The minus just means inverse. Everything looks the same once you change the minus to 1 and make it inverse. So this will give me 1 over. This 3 outside here is affecting both the a and the 7, since it's outside, since the 2 are inside the bracket. So I'm going to write my answer here as 1 over 7 cube times a cube. That will give me 1 over 343 a cube. Let me write my cube very well so you don't get confused. Question G. In question G, I'm to do h raised to power 8 divided by h raised to power 2. That gives me h raised to power 8 minus 2. That gives me h raised to power 6. Question H. Question H. Let me try and change my colors. Question H is 16v raised to power 7 divided by 2v. First of all, 16v raised to power 7 divided by 2b. 2v is the same thing as 2v raised to power 1. So I can put the questions above one another like this. 2v raised to power 1. This will change to 16 over 2 times v raised to power 7 over v raised to power 1. 16 over 2 is 8 here. 2 here 1, 2 here 1, 2 here 8. So that's 8 times v raised to power 7 divided by v raised to power 1. I can put brackets if I like. That will give me 8 times v raised to power 7 minus 1. 8 times v raised to power 6. 8v raised to power 6. Let's go to question I. Let me try and make this better. Let's go to question I. Question I is 2m divided by 8m raised to power minus 3. So that's 2m over 8m raised to power minus 3. So that's 2 over 8 times m over m raised to power minus 3. 2 over 8 is 1 over 4 times m divided by m raised to power. I'm sorry, let me make this a dot. minus 3. That gives me 1 over 4 times m raised to power 1 divided by m raised to power minus 3. That's 1 over 4 times m raised to power 1 minus 3. I hope you understand why those two sides are together now. 1 plus 3. That's 1 over 4 m raised to power 4. I can write my answer like that, or write m raised to power 4 over 4. Now, question G. 3 open bracket 3a raised to power 3 over 9a raised to power 7 0 times 3 x raised to power minus 1. Everything in this bracket will become 0. I think I should choose a color for them. Everything inside this bracket becomes 1. I'm sorry, 1, not 0. Because anything raised to power 0 is what? 1. So my answer for that will be 3 times 1 times 3x raised to power minus 1. That's 3 times 3x raised to power minus 1. That's what? That gives 9x raised to power minus 1, or 9 times 1 over x, or 9 over x. Yeah, so I choose. Question K. Open bracket 8 raised to power minus 1, 8 raised to power minus 1 bracket ry squared over 4ry cubed raised to power 0 times 8x, then raised to power minus 2. Everything in this bracket raised to power 0 will be equal to 1. So my answer will be 8 raised to power minus 1 times 1 times 8x raised to power minus 2. Now, 1 times 8 here is what? 8. So that gives 8 raised to power minus 1 times 8x raised to power minus 2. 8 raised to power minus 1 is 1 over 8 times 8x raised to power minus 2. 8 will divide 8. Let me choose a color. Let me choose a different color for that. 8 will divide 8. What does that give? That gives x raised to power minus 2, or 1 over x squared. Is that clear? That was question 2K. Let's see if we still get more. I think we do. So L now. Question L is 2 times 4 raised to power 6a times 16a raised to power 3. I'll put the numbers together. 2 times 4 raised to power 6 times 16 times a raised to power 3 times a raised to power 3. This will give me 2 raised to power 1. 2 is 2 raised to power 1. 4 raised to power 6 is 2 squared raised to power 6. Then 16 is what? 2 raised to power 4 times a is a raised to power 1 times a raised to power 3. I'm writing a raised to power 1 for this a. A raised to power 1 here stands for this a standing alone. Then times a raised to power 3. This 4 here is the same thing as 2 squared. So 4 raised to power 6 is just like 2 squared raised to power 6. And 16 is 2 raised to power 4. So let me go ahead and simplify now. This will give me 2 raised to power 1 times 2 raised to power 2 times 6 is 12 times 2 raised to power 4 times a raised to power 1 times a raised to power 3. That's 2 raised to power 1 plus 12 plus 4 times a raised to power 1 times a raised to power. Let me put this together once and for all. A raised to power 1 times a raised to power 3 is a raised to power 1 plus 3. Exactly. A raised to power 1 plus 3. So my answer on next step is 2 raised to power 17 a raised to power 14. If I'm leaving my answer in index 1. Let's go to M. Let's go to question M. Question M is 10p raised to power 5 q r raised to power 3 divided by 5p raised to power 3 r. This is the same as 10p raised to power 5 q r raised to power 3 q q r raised to power 3 over 5 p raised to power 3r. So 5 here 1, 5 here 2, that gives 2. Then this is p raised to power 5 minus 3, and this is q alone. Then r raised to power 3 minus 1, because this is what? R raised to power 3. This is r raised to power 3 divided by r raised to power 1. So that's r raised to power 3 minus 1. This is p raised to power 5 divided by p raised to power 3. P raised to power 5 divided by p raised to power 3. Just like they are under each other here. Is p raised to power 5 minus 3. And that's q r raised to power. So my answer is 2p raised to power 2 q r raised to power 2. Let's go to question N. Question N is 60c raised to power minus 5. 60c raised to power minus 5 divided by 12c raised to power minus 3. 60c raised to power minus 5 divided by 12c raised to power minus 3. I'll put them over one another. 60c raised to power minus 5. 60c raised to power minus 5 over 12c raised to power minus 3. That gives me 12 here 1, 12 here 5. That's 5c raised to power minus 5 over what? C raised to power minus 3. That's the same thing as 5 times c raised to power minus 5 divided by c raised to power minus 3. So that's 5 times c raised to power minus 5 minus 3. Minus 5 minus 3. So that's 5 times c raised to power minus 5 plus 3. And that's going to give me 5. That's going to give me 5 times open bracket c raised to power minus 5. I'm sorry, excuse me. Minus 5 plus 3 is minus 2. So minus 2. So this is 5 times 1 over c raised to power 2. C raised to power minus 2 is the same thing as 1 over c squared. So my final answer is 5 times 1 over c squared, or 5 over c squared. Is that clear? Let's go to question O. In question O, I have 9x raised to power 3 y raised to power minus 4 divided by 3x y raised to power minus 4. So 3 here 1, 3 here 3. That gives me 3x raised to power 3 minus 1, because there's 1 in y raised to power minus 4 minus 4. Because I'm using y raised to power 4 here. I'm using y raised to power 4 here. So I'm using y raised to power minus 4 here. I'm dividing y raised to power minus 4, by y raised to power minus 4. So I'll do y raised to power minus 4 minus 4. That's how division works. So this gives me 3x raised to power 2 y raised to power minus 4 plus 4. And that gives 3x raised to power 2 y raised to power 0, or 3x raised to power 2 times 1, because y raised to power 0 is what? 1. Y raised to power 0 is 1. So my final answer is 3x squared. Is that clear? Let's go to question P. I think we are almost done with this exercise. Question P is 1 over 81 open bracket 3 raised to power 3 minus 3 raised to power x minus 1. That's the same as 1 over 81 open brackets 27 minus 3x raised to power minus 1. X minus 3x minus 3 raised to power x minus 1. Let me multiply. This will give me 1 over 81 times 27 minus 1 over 81 times 3 raised to power x minus 1. 3 raised to power x minus 1. 27 here 1, 27 here 3. That's 1 over 3 minus. This 3 raised to power x minus 1 is the same thing as 3 raised to power x divided by 3 raised to power 1. Then there's another 81 there. I think I should write that step by step. So let me just write minus 1 over 81 times 3 raised to power x divided by 3 raised to power 1. This is where 3 raised to power x minus 1 came from. It should be 3 raised to power x divided by 3 raised to power 1. It is 3 raised to power x divided by 3 raised to power 1 that gives you 3 raised to power x minus 1. So that what does that lead to? That's 1 over 3. 1 over 3 minus 1 minus 1 minus 3 raised to power x over 81 times 1 over 3. I'm trying to bring out a 1 over 3 from here. I'm trying to bring out a 1 over 3 from here so that the factor will be here and here too, and I can simplify. So this is 3 raised to power x times 1, or just 3 raised to power x. So this 3 underneath can be written as 1 over 3 times 3 raised to power x. It is that 3 raised to power x that I have brought in, and I have, placed it above 81, and I've taken 1 over 3 out. So I can factorize. Let me rewrite that step. 1 over 3 minus 1 over 3 minus 3 raised to power x over 81 times 1 over 3. 1 over 3 minus 3 raised to power x times 3 raised to power x over 81 times 1 over 3. That's going to give me 1 over 3 is here. 1 over 3 is common to both. It's here and it is here too. So I'm going to write 1 over 3, open bracket, 1 minus 3 raised to power x over 81. That will give 1 over 3. 1 over 3, open bracket, 1 over 1 minus 3 raised to power x over 81. That will give me 1 over 3 LCM. What's my LCM? 3 raised to power 4. Or let me just write 81. Then 81 minus 3 raised to power x. So that's 1 over 3 times 3 raised to power 4 minus 3 raised to power x over 81. So that gives me 1 over 3 times 3 raised to power 4 minus 3 raised to power x over 81. Previous step. Now this is the same thing as 1 over 3 times 3 raised to power 4 minus, I think I've taken this too far. Let me go back a bit. I'm simplifying, so anything short and simple will be what should be my answer. I'm just supposed to write 1 over 3 outside, 1 minus this 3 raised to power 4 minus 3 raised to power x over 81. I think I'm okay here. I should just write 1 over 3 times 3 raised to power 4 minus 3 raised to power x over 81. And that's going to give me 1 over 3 times 3 raised to power 4 minus 3 raised to power x over 3 raised to power 4. That's 1 over 3 times 3 raised to power 4, open bracket, 3 raised to power 4 minus 3 raised to power x. So that gives me 1 over, this is 1. 3 raised to power 1 plus 3 raised to power 3 raised to power 1 times 3 raised to power 4 is 3 raised to power 5. So 1 over 3 raised to power 5, 3 raised to power 4 minus 3 raised to power x. I can write a last step. 1 over 3 raised to power 5 is 243. 1 over 243, 3 raised to power 4 minus 3 raised to power x. That's a lot more simpler than what I had before. So last question Q. Question Q will be 1 over a raised to power 4x, open bracket, a raised to power 4x minus a raised to power minus 2x, a raised to power minus 2x raised to power 0. So this is pretty straightforward. This should just be 1 over a raised to the power 4x, open bracket, a raised to the power 4x minus 1. Anything raised to the power 0 is 1. All of this is raised to the power 0 here. So I'll just represent them with 1. So this. So my answer is a raised to the power 4x minus 1 over a raised to the power 4x. So I think that solves the problem. A raised to the power 4x minus 1 over a raised to the power 4x. If I need to simplify, a raised to the power 4x minus 1 over a raised to the power 4x will become a raised to the power 4x minus 1. 1 is the same thing as a raised to the power 0. 1 is the same thing as a raised to the power 0. So over what? Over a raised to the power 4x divided by a raised to the power 4x. So that will give me 1. I think, let me just leave it like this. It's simple enough like this. This is simple enough, at least it compresses the equation to a reasonable extent. That's my answer. That ends exercise 4.2.